Here is a story that happens every single week. A developer is working fast. Deadline tomorrow. They hard-coded database password directly in the config file. Push to GitHub. Done. Within 11 minutes, an automated bot finds it. Not a person, a bot. Scanning every commit, every repo, 24 hours a day. The database is accessed. Data is stolen. Company is breached. This is not a hypothetical. In 2023, over 10 million secrets were found exposed on GitHub. API keys. Database passwords. Cloud credentials. Most of them from developers doing exactly what I just described. Azure Key Vault exists to make this impossible. Your secrets live in a hardened vault. Your app retrieves them at runtime, no hardcoding, no config files, no risk. By the end of this video, you will know exactly how to set this up. Key Vault stores 3 types of sensitive material. First, secrets. These are simple key-value pairs. Database password. API key. Connection string. OAuth token. Anything you would otherwise hardcode, it goes here instead. Second, keys. Cryptographic keys for encrypting and decrypting data. The crucial difference: keys never leave the vault. Your app asks Key Vault to encrypt something. Key Vault does the operation and returns the result. The raw key material never touches your application. Third, certificates. SSL and TLS certificates for your services. Key Vault can even auto-renew them, so you never get that 2 a.m. alert about an expired cert. And here's the important part about security. Everything in Key Vault is encrypted at rest using AES 256. In transit, TLS. The premium tier uses hardware security modules, physical chips that store keys. The keys are FIPS 140-2 Level 2 validated. This is the same standard used by banks and governments. So how does your app actually get a secret without hardcoding it? At application startup, your app calls the Key Vault SDK. It requests the secret by name. Key Vault authenticates the request, checks permissions, and returns the value. Your app stores it in memory, never on disk, never in a config file. The code looks like this in practice. You pass in the vault URL and the secret name. The SDK handles authentication and retrieval. One line of code. No credentials in sight. But here's the catch. Your app still needs permission to access the vault. You cannot just call it and get everything. Access is controlled, and we will cover that next. What you should never do: store the vault URL and a password to access the vault in a config file. That defeats the entire purpose. The right answer to this problem is managed identity. And that is the part that makes Key Vault genuinely elegant. This is where it gets genuinely elegant. The question was, your app needs a credential to access Key Vault. But if you store that credential somewhere, you are back to the original problem. Managed identity solves this completely. Azure assigns your app service, your function, your VM, any Azure resource, a special identity. No password. No certificate. No token you manage. Azure handles the authentication internally using its own infrastructure. Your app calls Key Vault. Key Vault sees the request coming from an identity it trusts, the managed identity. Access granted. Secret returned. Your developers have 0 credentials to manage. 0 credentials to accidentally commit to GitHub. 0 credentials to rotate when someone leaves the team. Now this is where most people get it wrong. They use managed identity correctly for production. But then they still hardcode credentials for local development. The Azure SDK supports default Azure credential. It works with your developer account locally and automatically switches to managed identity in production. One code path. Both environments covered. Key Vault has two ways to control access. The old way, access policies. You assign permissions at the vault level: read all secrets, write all secrets. It is simple, but coarse. One app that needs one secret gets access to all secrets. That is too much permission. The new way, Azure RBAC. Role-based access control. The same system used everywhere else in Azure. You assign a role: Key Vault Secrets User for read-only, Key Vault Secrets Officer for management. You can even scope it to a single secret. Here is the real-world pattern. Your app service managed identity gets Key Vault Secrets User on the specific secrets it needs. Your operations team gets Key Vault Secrets Officer to rotate and add secrets. Your developers get no access in production, they use separate dev vaults. And here is a mistake I see constantly. Teams give their app Key Vault administrator the most powerful role. The app only needs to read one connection string, but it has permission to delete the entire vault. Always assign the minimum role required. Nothing more. Here is a scenario every team eventually faces. Your database password needs to be rotated. Security policy, every 90 days. Without Key Vault, this means updating config files, redeploying apps, hoping nothing breaks. With Key Vault, you update the secret in the vault. Your app retrieves the new value on the next call. No redeployment. No downtime. But here's the part nobody talks about. What happens during the rotation window? Some app instances have the old password cached. Some have the new one. If you rotate instantly, the old instances fail. Key Vault handles this with versioning. Every update creates a new version. You can keep both the old and new version active simultaneously. Old instances keep working. New calls get the new version. Once all instances have refreshed, delete the old version. Zero downtime rotation. Zero redeployments. And for teams who want to automate this entirely? Key Vault integrates with Azure Functions to trigger automatic rotation on a schedule. Set it and forget it. Now pay attention here, this one matters for production environments. Key Vault has two safety features that most teams enable too late. Soft delete. When you delete a secret, it is not gone immediately. It enters a soft deleted state for a configurable period, 7 to 90 days. During that window, you can recover it completely. I have seen this save teams who accidentally deleted production credentials. Purge protection. This goes one step further. Even a vault administrator cannot permanently delete a secret during the retention window. Not accidentally. Not maliciously. If an attacker compromises an admin account and tries to destroy your secrets, they cannot. The vault holds them safe for the entire retention period. The cost of enabling both, 0. No performance impact. No extra billing. The cost of not enabling them, potentially catastrophic. Enable soft delete and purge protection on every production vault. Day 1. Not after the incident. Let me show you the complete pattern that every production Azure app should use. 3 resources. 5 steps. Step 1. Create a key vault. Store your database connection string as a secret. Step 2. Go to your app service. Settings identity. Enable system assigned managed identity. Azure assigns your app service an identity automatically. Step 3. Go back to Key Vault. Access control. Add role assignment. Role: Key Vault Secrets User. Member: Your app service's managed identity. Step 4. In your app service application settings, reference the secret. The syntax is at Microsoft.KeyVault, secret URI equals your secret URI. Azure resolves this at runtime, the actual value never appears in your config. Step 5. In your code, use default Azure credential. Locally, it uses your developer account. In production, it automatically uses the managed identity. The result, there is not a single hard-coded credential anywhere. Not in code. Not in config. Not in environment variables. The vault holds the secrets. The identity holds the access. Your app holds nothing. That is Azure Key Vault done properly. This is part 21 of the Azure series. If you are serious about becoming a cloud engineer, subscribe and keep going. Next up, Azure Monitor and how to catch problems before your users do. Let us bring it all together. Key Vault stores three things: secrets, cryptographic keys, and certificates. Everything encrypted. Everything access controlled. Everything audited. Your app accesses secrets through managed identity. No passwords to manage. No credentials to rotate. No secrets to leak. Use Azure RBAC for permissions. Assign only what is needed. Key Vault Secrets User for reading. Key Vault Secrets Officer for managing. Never Key Vault Administrator for your application. Use secret versioning for zero downtime rotation. Enable soft delete and purge protection from day one. The pattern is simple: app service plus managed identity plus Key Vault. 3 resources. 0 hard-coded credentials. Full audit trail. If you walked away from this video knowing just one thing: never hardcode a secret. Not in your code. Not in a config file. Not in an environment variable that gets committed. Every secret belongs in Key Vault. That is Azure Key Vault. This is part 21 of the Azure series. Subscribe and keep going. Next up is Azure Monitor.